Now we will talk about transformer ventilation system. Okay, as per the local regulations. Okay, as just now we have discussed about generator room, how to ventilate and what is the capacity. Okay, how to calculate, why it is required, everything. The same purpose for the transformer as well. Okay, the transformer, what it is doing, it transmit the power from HV to LV, right? So it carries the power. Okay, so when it carries the power, there is a work is happening. Okay, so what will happen based on that work, it will dissipate a heat because of the work input. Okay, it has to transfer the power from one place to another place, right? It is a transformer. It has to step down the from high voltage to the low voltage, right? Okay, so when the transformer works, what will happen, it dissipate a heat. Clear, right? So when it dissipate a heat, there is a lot of heat inside the transformer room. Okay, after some time, what will happen, due to the excess heat, the transformer will start giving inefficiency because of the excess heat inside the transformer room, right? So what is our purpose? We have to take out all the excess heat from the transformer room. Okay, so you're going to calculate the transformer ventilation capacity. How to take out all the excess heat from the transformer room. So that is what we are going to calculate. Clear, right? Okay, now this is one of the sample example. You can see this is one of the guideline, okay, where you can see the transformer, right? And where you can see the transformer is in enclosure. Okay, so whatever the heat dissipates from the transformer, it has to be taken out from the transformer room. Okay, so that is why we are going to calculate transformer ventilation fan capacity. Okay, so now to calculate your transformer fan capacity, this is the equation, transformer room ventilation. Okay, how to calculate transformer heat dissipation, this is the equation. Okay, what is the transformer kVA rating multiplied by number of transformer multiplied by power factor multiplied by 1 minus transformer eddy losses. Okay, so by using this equation, you can able to calculate heat dissipation of the transformer room. Okay, and what is the transformer kVA rating? This is based on the electrical design. Okay, what is the transformer they required to power the building, right? So like you have a 500 kVA, 1000 kVA, 1250 kVA, 1500 kVA. There are different type of power rating, right? So based on the power rating, there is a transformer kVA rating. Okay, multiplied by number of transformers. So how many transformer installed inside that particular room? Okay, multiplied by power factor. Power factor is nothing but the conversion from kilowatt to kVA. Okay, so that is a power factor. So when you multiply by power factor, multiply by kVA, the result will be kilowatt. So kilowatt is nothing but kVA multiplied by power factor. Clear, right? Multiply by 1 minus transformer eddy losses, which is nothing but efficiency of the transformer, which can be 98.4 or 99 percentage or 96 percentage, whatever the efficiency you are going to enter here. Clear, right? So that is 1 minus transformer eddy loss. Then you can calculate what is the loss. What is the loss in the transformer? If you have a 98.4, that means what is the loss? It will be 0.1 minus 0.984. So the loss will be 0.02, 0.016. That will be the loss. Clear, right? So now to calculate your heat dissipation, transformer kVA rating, which is nothing but 1250 or 1000 or 500, multiplied by number of transformer, multiplied by power factor, multiplied by 1 minus transformer eddy loss. So in that way, you can calculate your heat dissipation. Okay, and what is the equation for the heat transfer equation? BTU per hour is equal to CFM multiplied by delta T multiplied by 1.08. This is the equation. Okay, so in this equation, you can go through as well. So if you go through this HVAC equation, data sheet, rule of thumb, okay, if you go further down, you can see the air side equation, which is nothing but sensible heat, 1.08 multiplied by CFO multiplied by delta T, correct? So remember, sometimes back we have seen what is sensible load, what is latent load. So sensible load is purely equipment load. Okay, so that is why you are going to calculate by using this equation. Okay, so H is nothing but sensible heat BTU per hour equal to 1.08 multiplied by CFM multiplied by delta T, right? So if you go through the equation, what is the delta T? Maximum delta T allowed 7 degree Kelvin. Even if when you go through the ASHRAE guideline, also they have given design outdoor plus 7 degree Celsius, right? So here also the guideline also giving the temperature difference, which is 7 degree Kelvin. Okay, so say for example, a maximum ambient temperature in Dubai is 48 degree Celsius plus 7 degree. The maximum transformer can work up to 55 degree Celsius. More than that, it cannot work. Okay, basically it will have a less in efficiency, or it may generate more heat. Okay, which may happen inefficiency of the transformer. That is why you have to maintain the temperature within the delta D T equal to 7 degree Kelvin. Okay, so now if you go to the equation, we know the heat dissipation, right? And we know the delta T. So balance is CFM. So the CFM is nothing but sensible heat divided by delta T divided by 1.08. Okay, so 1.08 you can divide, delta T is nothing but 7 degree, right? 7 degree Kelvin. So if you have to convert into Fahrenheit, it will be 13 degree Fahrenheit. So say for example 48 degree to 55 degree, which is 7 degree. Okay, but when you convert into Fahrenheit, you will get a difference of 13 degree Fahrenheit. Okay, so that if you apply in this equation, you can able to calculate the CFM of the fan. So which is nothing but the fan capacity. Does anyone have doubt?